It is important to understand what a reference angle is as we move forward in trigonometry. So first of all, let's just define what a reference angle is. If you draw any angle in standard position, there is always going to be a reference angle. A reference angle is the positive acute angle formed by the terminal side of the angle and the x-axis. It's always in relationship to the x-axis. Notation-wise, if your angle's name is theta, then the reference angle is denoted theta prime. The figure that I have shown here is given to you to show how reference angles always work. If your given angle ends in the first quadrant, then your reference angle is just from the x-axis to that terminal side. If your original angle ends in the second quadrant, then your reference angle is from the x to the terminal side. If your original angle ends in the third quadrant, your reference angle is from the terminal side to the x. And then for a fourth quadrant original angle, your reference angle is from where you ended to the x. In example 11, we are asked to find the reference angle for the given angle. And the first one we are asked to do is for theta of 75 degrees. The first thing that you should always do is just go ahead and sketch where 75 degrees is. Well, 75 degrees is going to be in the first quadrant. So theta is 75 degrees. There's my graph. Now the thing is, if I'm in a first quadrant, then from x to that terminal side will also be my theta prime. So theta prime is also 75 degrees. So our reference angle is 75 degrees. For question B, the theta that we are given is negative pi over 8. If we set up an axis and think about drawing negative pi over 8, the negative means that we need to go down. So we are going down pi over 8, which isn't really very far. So there's theta, and it is pi over 8. Your theta prime is always from where you stopped to the x. So our theta prime is going to be from where we stopped to the x. It's going to be the same angle, but reference angles are always positive. So our theta prime, it's the same distance, it's pi over 8, and it's always positive if it's a reference angle. So our theta prime is pi over 8. For problem C, the angle that we are given is 210 degrees. So if we set up our axes and then we sketch 210 degrees, we're going to start at 0. Going to the negative x takes us to 180, so we need to go another 30 degrees into the third quadrant. So there's theta of 210 degrees. The reference angle is always from where you ended to the x. So our reference angle is from where we ended back up to the x. What was that measure? Remember that we, in sketching 210, said we went 30 past 180. So our theta prime is 30 degrees. For D, our given theta is negative 120. So set up our axes. Negative means we're going to go down. We hit the negative y-axis, that's negative 90, so we need to go 30 past that. And there is our theta of negative 120. We ended in the third quadrant, and any time that you end in the third quadrant, your theta prime is from the terminal side up to the negative x-axis. So there's theta prime. What we have to figure out is, how much is that? Now remember, to make up this negative 120, the fourth quadrant we used 90 degrees, and we used 30 more degrees of the third quadrant to total 120 degrees. So that means that what's left of the third quadrant to be theta prime is 60 degrees. And again, remember, reference angles are always positive. On example E, we are asked to find the reference angle for theta of 10 pi over 9. So let's think about that. 10 over 9 is more than 1. It's 1 1/9 pi. So if we go from 0 to the negative x, that's 1 pi. We need to go just a little bit beyond that into the third quadrant. So there is our theta of 10 pi over 9. We want theta prime. We're in the third quadrant again, so theta prime is from where we ended back to the x-axis. How far did we go? Remember that this was pi. Pi could be thought of as 9 over 9 pi. How far past that did we go? 1/9. So theta prime is 1/9 pi, or pi over 9. Our last example for reference angles has a given angle theta of negative 28 pi over 15. Before we even start sketching this, I want to think about something. 1 pi equals 15 pi over 15. What I always do is look at my denominator and think about what 1 pi equals and what 2 pi equals to help me figure out where I need to go. 2 pi, if you want something over 15, well, to get 2, you need to have 30 over 15 times pi. So now that we know where 1 pi falls and where 2 pi falls, let's think about sketching this. We want to go negative 28 over 15. So we want to go almost to 2 pi. So what that means is for theta, we are starting at 0, going down almost all the way around and ending in the first quadrant. So there's our theta of negative 28 pi over 15. We need the reference angle. Well, if you have fallen in the first quadrant, with your terminal side, then your reference angle is from the x-axis up to your terminal side. We went 28 out of 15, and if we over 15, and if we had gone 2 pi, it would have been 30 over 15. So how far did we fall short from that? 2/15. So theta prime is 2 pi over 15.